Hello, welcome to Shine Solutions. In this video, we will discuss 2022 JAM Chemistry, question number 21 to 30. This is the third video based on the JAM 2022 question paper. Okay, so let's start. This is the 21st question. The reaction of 2,4-dinitrofluorobenzene with hydrazine produce a yellow orange solid X used for the identification of an organic functional group G, X and G respectively are. This is the question. So these are the options given. So let's see how to solve this. To solve this question, so this is the molecule given, fluorine, NO2, NO2. Okay, 2,4-dinitrofluorobenzene, and this is treating with hydrazine NH2, NH2. Okay, what happened is this will attack here and fluorine will be eliminated. So we will get the product like this. NH2, NH2, sorry, NH, NH2, NO2, NO2. Okay, this is the product you will get. So this reaction is used for the identification of aldehyde. So what is the option given is, so let's see what is the option. So this is the product you will get, this is the product you will get, and the option given is aldehyde. So first option is the correct answer. Okay, so this is the first question. So next question, 22nd question. The stability of adduct H3B PF3, H3B NME3, H3B CO, H3B OME2 follows the order. So this is a very good question. You can expect the same type of question for the next exams also. So you should prepare for it. So how can we approach this problem? You can see here a BH3 is given. Okay, we know BH3 is a Lewis acid. The octet is not completed for this species, only 6 electrons around boron. So it's a electron deficient system. So it need electrons to complete the octet. So whenever it get electrons, it will be stable. That is how we should approach the problem. So that means this is a Lewis acid. Okay, so better Lewis base can stabilize this acid. So among the options given, which are the best Lewis base which can stabilize this pH 3, that is how we should approach the problem. So if you look at the options, we are given NME3, okay, and CO, OME2 and PF3. Okay, so which is the better Lewis base among these? That's what we should find out. So we know NME3 can provide electrons, it's a very good base, and CO is also a good base. OME also can provide. PF3, everyone can donate electrons, and all of them are bases, but the basic ability is different. Okay, so if we compare the basic ability, we can see phosphorus. Phosphorus is not a good base. Phosphorus will not give its lone pair to other species. It's not a good base. And when fluorine is attached to phosphorus, fluorine will pull the electrons from phosphorus. So the basic ability again reduces. Okay, so this is the least basic among this. Least basic. And NME3, if you look at the NME3, nitrogen is a very good base, we know that. And Me is a electron donating group. Okay, and all Me will donate electrons towards nitrogen, and this will increase the electron density of nitrogen, so it will make it a better base. So this is the highest base, high basic ability for NME3, and least basic will be for PF3. So if you look at the options, this option D is given like that. Okay, NME3 is the most basic one and PF3 is the least basic. So option D is the right answer. Okay, now we'll move on to question number 23. So this is also an excellent question, very good question. So it's about rotational spectra. So the spacing between successive rotational energy levels of a diatomic molecule xy and its heavier isotopic analog x dash y dash varies with the rotational quantum number Js. This is the question given. So let's see how to solve the question. It's a very good question. So we know, according to rotational spectra, energy of a diatomic molecule is given by molecule is given by Ej equal to Bj into J plus 1. This is the equation for energy of a diatomic molecule. Bj into J plus 1. Okay, E J plus 1 will be equal to B J plus 1 into J plus 2. Okay, so if we take E J plus 1 minus Ej, what we will get is B Bj, okay, Bj square plus 2J plus J plus 2. Okay, so this is Ej plus 1. So I am writing about Ej plus 1. Okay, so it will be a Bj square plus 3Bj plus 2. Okay, so if we take Ej, it will be Bj square plus 2B, sorry, B plus B. Okay, so if we take the difference, Ej plus 1 minus Ej, it will be Bj square minus Bj square. These two will be cut out, and 2B minus B. Okay, it will be 2Bj 2B 2Bj plus 2. So that's what we will get. So Ej plus 1 minus Ej will be equal to 2B into J plus 1. Okay, this is the equation you should remember. So we should use this one. Okay, Ej plus 1 minus Ej will be equal to 2B into J plus 1. Okay, so we can use that equation to solve this question. So that is about Ej. What about the E dash? If we think about the heavier isotopes, X dash, this is for XY. If we take for X dash Y dash, okay, X dash Y dash, we'll take B as B dash. Okay, so what is the equation for B? B equal to H by 8 pi square IC. Okay, I equal to mu R square. Mu R square. Okay, mu is the reduced mass. Mu equal to m1 m2 divided by m1 plus m2. Okay, so from this, if mass of the atoms increases, what happens? I value will be increases. I value increases means I is at the bottom. So if I increases, B decreases. Okay, so we can say B is greater than B dash. Okay, so B is greater than B dash. So that is what the information we'll get it from these equations. So if we substitute, if we compare the Ej plus 1 and Ej for B and B dash, so we can write it like this. For XY system, we have Bj into 2B into J plus 1. So this is for X dash Y dash, we have 2B dash into J plus 1. Okay, so this is what the information we will get. So this is the information we have now, and we know one more thing: B is greater than B dash. These are the information we have. So if we multiply this, we will have Ej equal to Ej plus 1 minus Ej will be equal to 2B into J into J plus 2B. Okay, so if you look at the options, in the y axis we have Ej plus 1 into J, Ej plus 1 minus Ej, and in the y axis, x axis we have J. Okay, so this is in the y equal to mx plus c form. Okay, so if we have y is this one and x is this one, this is x and this is y. Okay, so if you look at this equation, this is very much similar to this one. This is y, this corresponds to y, and this corresponds to this j is x. Okay, that is what is given here. Okay, so if you look at if you compare these two equations, you can see m equal to 2b and c equal to 2b. Okay, m and c are 2b. Okay, so for xy systems it will be 2b. This is for xy systems. Okay, for x dash y dash system it will be 2b dash and 2b dash. Okay, and we know one more thing, b is greater than b dash. Okay, so what is m? M is the slope of the peak. Okay, slope means this is the slope. Okay, this is the slope. And what is c? C is the intercept. Intercept means this value. Okay, this value is intercept. Okay, this is the intercept. This is c and this is m. Ready? Okay, so it has a significant value for intercept. So there is intercept 2b dash. It is not 0. So we can eliminate this option first option, because this is starting from the origin. So definitely this has a value. So we can eliminate option A. And if you look at the option B, we can see for x dash y dash we have 2b dash, and b and b dash are not same, it is different. So we have this information, b is greater than b dash. Okay, so b is greater than b dash means option B also can be eliminated, because in this value both the intercepts are same for option B. So option B can also be eliminated. So if you look at the option C and D, we can have different values for intercepts. So option C and option D can have answers. So to discriminate option C and D, we should go for M. The slope is different. Slope is also 2b and 2b dash. Okay, so slope is different. B is greater than b dash, so B should have high slope. Okay, in this case you can see option C, both the slope are same. Okay, but in this case option D we have different slopes. Okay, so option D is the right answer. Okay, so this is the answer for question number 23. I think you got the answer. And this is also a very good question. This question says the ratio of 2p to 1s transition energy in helium to that of hydrogen atom is closest to. Okay, the ratio of, so what is the energy? Energy of orbitals is given by E is equal to for hydrogen like species we know minus 13.6 into z square divided by n square. Okay, this is the equation to find out the energy. Okay, so 2p to 1s transition, that is what we should calculate. Okay, so first we should calculate for hydrogen. For hydrogen system it will be E1 to for E1 epsilon E for hydrogen atom, E1 will be minus 13.6 into 1 square divided by 1 square. Okay, it will be minus 13.6 EV. Okay, and E2 system it will be minus 13.6 into 1 square divided by 2 square. It will be equal to minus 13.6 divided by 4. Okay, so E2 minus E1 minus E2 will be like this. E2 minus E1 will be equal to minus 3 by 4 minus 3 by 4 into 13.6. Okay, so this will be the E2 minus E1 for hydrogen. Okay, so E2 minus E1 for hydrogen is like that. So we will notice for hydrogen E2 minus E1 will be 3 by 4 into minus 13.6. Okay, similarly for helium. Okay, so for helium, so what is the value for helium? Helium, it will be minus E1 will be like this, minus 13.6 into z square by n square. Z square will be 2 square divided by 1 square. Okay, it will be 4 into minus 13.6. Okay, for E2 system, it will be minus 13.6 into 2 square divided by 2 square. It will be minus 13.6. Okay, so E2 minus E1 will be E2 minus E1 will be minus 1 minus 3 into minus 3 into 13.6 EV. Okay, so if we compare, this is for helium. So what is the ratio of 2p to 1s transition energy for helium to, so helium to hydrogen? Okay, so it will be helium. So what we should find out is E2 minus E1 for helium divided by E2 minus E1 for hydrogen. That is what we should find out. Okay, it will be equal to minus 3 into 13.6 divided by 3 by 4 into 13.6. Okay, it will be cancel out. It will be 4 into 13.6. It will be, answer will be option C. Okay, so this is the answer for question number 24. Ready? So let's move on to the next question. This is the direct question. There is no application, just by heart and reproduce the ideas. The phase diagram of water is best represented by. So if you study, you can see option D will be the right answer. So there is nothing to say about this direct question. Option D is the right answer. Okay. Pressure and temperature should be at y and x axis. Okay, that's what you should look for. Next question, and this is also a good question. The capillary W contains water and capillary M contains mercury. The contact angle between the capillary wall and the edge of the meniscus at the air liquid interface in W and M are theta W and theta M respectively, the contact angle satisfying the condition. Okay, so if you look at the questions, you may think it's a complicated question. Actually, it's not that much difficult. The idea is, if you look at the this picture, you will get the idea. So water will be, if you place the water, it will be like this. The angle will be like this, concave angle. So it will be like this. Okay, for water, and it will be like this for mercury. Okay, so that's the idea. So if you look at the options, so in this case both are same. If you look at the options, both the angle are similar. It will not be like that, it should be in the opposite. Okay, so in this is opposite and this is also same, so we can eliminate these two options. Okay, so if you look at picture, you can see for water it will be greater than 90 degree and for mercury it will be less than 90 degree. So answer is option C. It's a very tough question actually. 27th question. The Maxwell-Boltzmann distribution of one-dimensional velocities Vx at the temperature T is given A is a normalization constant. So what are this is the, we should find out the Maxwell-Boltzmann distribution of one-dimensional species. Okay, so this we should by heart the equations, but this is actually a tough question. But if you look at the previous question papers in 2011 JAM chemistry, the same question is asked like this. If you already prepared this one, it is a very easy answer. So if you, the same question is this, I took it from the 2011 question paper, 2011 JAM chemistry, question number 39. It's the same question. So answer is option A for this one. This is the question number 28. The potential of a particle in 1D box is given as V of x equal to 0 for x equal to 0 to L, and V of x is infinite elsewhere. The location of the internal nodes of eigenfunction psi of x equal to n is greater than or equal to 2r. Okay, so this is a question from quantum chemistry, and to find out the nodes, what is the equation to find out the nodes? This is not a tough question, actually it's a easy question. To find out the nodes, we should know nodes equal to number of nodes equal to 1 minus n minus 1 divided by n. Okay, 1 to n minus 1 divided by 1 to n minus 1 divided by 1 into L. This is the equation for number of nodes. Okay, so if you look at the options in the denominator, it is n. So in the options, this is n plus 1 and this is n plus 1. So we can eliminate these two options. Okay, so if you look at the option A and B, so this part should be an integer. So that is the condition. Okay, so it should not be a fraction. Option A is a fraction, so option B is the right answer. This is the answer for question number 28. Question number 29. So this is the question. The number of CO stretching bands in the infrared spectrum of FeCO 5 times. Actually, this is a high level questions. Usually these type of questions asked for NET exams. For JAM exams, we usually do not expect this type of questions, because to solve this question we should know the group theory. If you know the group theory and if you know to find out the point groups, it will be very easy. Otherwise it's a bit tough. So I am explaining based on group theory this question. So the structure of FeCO 5 times. This is a trigonal bipyramidal molecule. Trigonal bipyramidal molecule. CO. This is the molecule. CO, 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 CO. This is the structure of the molecule. The point group will be D3H. Okay. If the point group is D3H, the number of IR stretching value will be 2. So the answer is option B. Okay, and last question, this is the question number 30. The standard Gibbs free energy change for the reaction. The standard Gibbs energy free for the reaction is given like this. So this is a direct question, very easy question. So what is the equation for calculating free energy? Delta G0 equal to minus RT ln K. So this is the equation. So all the things are given. Delta G is given. Delta G is 118 kilojoule. It should convert it to joule. Then R equal to 8.314 joule per Kelvin per mole. Okay, and we should find out the K. T is temperature is given 2500 Kelvin. Okay, all the values are given. Direct substitution, if you calculate it, you will get option C is the right answer. Okay, so this is the question up to 30. In the next video we will meet again next week. Then we will discuss the question number 31 to 40. Okay, bye.